here's like, those are pretty messy addresses, Jack's Place. But anyway, that's what entity resolution looks like if you've never seen it. Back to here. What I thought I would do next for fun is do something called slow motion entity resolution. It took 30 hours to make these 10 charts. It goes pretty quick, but it's a little mini class in entity resolution. Take a look at those 3 records, and I want you to imagine whether this is 1, 2, or 3 people. You know, the names are all similar. The first and third address are close enough. The date of birth on the first and second record are different, but only the month and day are transposed. This phone number ending in 1214 is similar, but they're all structured different. Most people, by the way, if I do that in a room, you'd be surprised what the diversity is, but that's just good old-fashioned fuzzy matching. So those 3 come together into E1. Now you get this record, Patricia Smith. It's got exactly the same email as Robert. You know, many times email is a great way to put people together, but sometimes family members share email addresses. So you can't put that together. So we call that a discovered relationship. So it's starting the graph. While I'm on the subject of relationships, here's a disclosed relationship. Say you're opening up a utility account or a bank account, and they told you who their spouse is. Kim gets the account and says, hey, my spouse is Rob Smith. Okay, great. That's a disclosed relationship. Now it's going to get a little more interesting. Take a look at this record and compare it primarily to record 1. Would you say it's the same person for sure? Bob R. Smith, Robert Smith, same date of birth. Or would you at best only be able to say it's possibly the same? Well, in fact, you're probably right. It's really just a possible match. It's just not enough information to be sure. So we would graph that and call it possible match. Now this one here is particularly tricky. I've wanted to make this work for a decade, and I never was able to get the money spent in engineering time to work on this. Take a look at 7. Is it record 1 or 4? Most entity resolution systems will arbitrarily assign that to 1 or 4. Or like, what if it just had the word street on it? It would make it a little bit more like this record, because this one also has the word street on it, as if Patricia doesn't live on a street. Now, if record 7 was like bad credit, or be on the lookout for as a child abductor or something, man, you don't want to arbitrarily give this to 1 or 4. I mean, it's 50-50 wrong. You'd be maybe impacting somebody's civil liberties and knock down the wrong door. So that needs to be held out as another type of possible match. Just, I mean, to be really more clear about this, if entity E2 didn't exist, you could be pretty darn sure it was E1. And if Robert didn't exist here and you only had Patricia here, you could be pretty sure this record was here, but because they both exist. Okay, now it's going to get a little more tricky. Record 8, compare it primarily to record 2. B. Smith, Bob Smith, same address, same phone ending in 1600. Record 8 is going to add to record E1, but something else can happen. If you knew that record 8 was part of entity 1, can you ponder for a moment what else you should be able to then know? See, if 8 were to combine into here, then entity E1 would learn this email address, bsmithatwork.com. And well, heck, if you knew that this entity here was also bsmithatwork, then you'd realize record 6 was not just a name and a date of birth. It was a name, a date of birth, and email address. And so the moment record 8 arrives, record 6, the possible match from the past, self-corrects. That's an example of entity resolution, learning in real time, and then fixing the past. Okay, now record 9, just a couple more moves. This record, compare it primarily to record 3. Same name, same ID, same driver's license. Great. But guess what? That date of birth ending in 54. Record 1 and 2 are 78. Can't stick record 9 into E1. So record 9 is going to appear right here. But the moment record 9 lands here, something else is going to happen. It's going to fix this false positive. Every now and then you'll get a false positive where you'll put a junior and a senior together. But, you know, hundreds, thousands, or a billion records later, when you learn record 9, it pulls record 3 out. I want you to imagine that for a minute. You've made a billion decisions about who's who and who's related to who, and then you get record 9. Not only do you have to figure out if it's a new person or a known person, but you have to ask yourself, now that I know that, had I known that in the beginning, over the billions of decisions I've made, should I have made any of them differently? That turns out not to be trivial to do at scale and in real time. And it's probably one of the hardest things to do, in fact. And if you can't do it, the accuracy of your system drifts. If you're loading new records and you can't fix the past, I've been told by a big data aggregator they were drifting at 1% a month. So let's say at the beginning of the month they have a 1% error rate, but 1 quarter later they're at a 4% error rate. So they just tear it down and reload. And then over the next quarter they just slowly drift with error and then they reload. These type of systems are unstable. They require periodic maintenance. This means, you know, whether you're dealing with a border or you're dealing with financial fraud at a bank or in healthcare, waiting 90 days to realize, you know, these two people are really the same, the fraudster's back, is just an awful big window for bad guys to operate. What we've worked on is something called sequence neutrality. It means, did you get record A first, then B, then C, or C first, then B, then A? And this is a world where new observations reverse earlier assertions, so there's no reloading. Okay, I think two more moves, but this one catches up most people. Record 10. Well, compare it to record 1 and you'll find out only has an address in common. So you can't resolve it to record 1. And it only has a phone number in common and a different last name, Jones and Smith. You can't resolve it to record 2. Record 3, it matches the AKA, but nothing else. It doesn't match any of those records. Most entity resolution systems out in the world do record matching, which means it can't match record 10 and it has to create a new identity. But if you knew that record 1, 2, 6, and 8 were all part of E1, and you could, you know, peek into this, call it folder, and see all the different names and all the different addresses and all the different emails and AKAs, you would realize that 10 is actually that identity. And we call that entity-centric learning. And this turns out to be super important in catching clever bad people. Now, entity resolution gets used for marketing and humanitarian things, but man, we've had some real fun using it over the years, or our customers have, in catching clever bastards. And here's how that works: is the primary deception tradecraft of bad people I call channel separation. And basically what that means, no clever bad guy uses the same name, address, phone, and passport on every record. Only the idiots would do that. By the way, you and I do this some too. Like if I were to email you an encrypted document, but then call you with the password, that's channel separation. Boy, I'll tell you, this holds true from simple card counters trying to penetrate Vegas all the way to terrorists trying to sneak into the US. And the only way to actually find them is to figure out how to do this. And the way that's done is entity resolution that uses entity-centric learning, not record matching. Okay, I think I got one more move. You know, GDPR, California's CCPA, other privacy laws, you loaded a record by accident and now you don't want to reload everything, you just kind of like want to delete one record. What if you delete record 8? Well, if you delete record 8, you have to unlearn that 6 was a possible match. We think of it as data tethering, like every add, change, and delete, you can support atomic level add, change, and delete, and then fix the past. This is support for other character scripts. These are companies instead of people. These are vessels instead of other things. And this is like with anonymized features. But anyway, that's a step through of some of the more important things that you need to be able to solve in entity resolution to maintain an active or current graph. I'm going to pause for a second here and see if there's any burning questions right now. Any burning questions?
We don't have any in the chat.
Okay. Does anybody want to?
Please feel free to raise your hand, or anybody jump in.
Yeah, jump in and ask a question. Okay. Well, I'm going to try to zip through the rest of my charts in 10 minutes and saving 10 minutes for Q&A. Is that okay? I'm going to assume that's okay and press on.
It's perfect. Thanks, Jeff.
Okay. Okay, great. Places and organizations where you're going to find entity resolution is, looking for clever bad folk. Risk analysis, where you're trying to see whether, they should be given the opportunity, for the, like employment background checks might be here, or credit and lending. Customer 360 and visibility into networks and customer value. And there's other uses. It's like if anybody's using Neo4j or Janus Graph, or Titan Graph databases, doing entity resolution on graphs really improves the quality of graph analytics. I'm going to have an example of this in a minute on enhancing machine learning models. It also improves privacy. You can be used for privacy compliance. But to be more specific, like in financial services, putting some actual words for financial sector in here, it's like first and third party fraud, OFAC and PEP, KYC, customer due diligence, enhanced due diligence are other examples in financial services. If you're in government space, entitlement fraud, tax fraud, insider threat are very popular. Doing citizen master, creating central indexes for CCPA or GDPR to better service data subject access requests, retail, blah, blah, blah. Here's this machine learning example for you. This is Vioxx. Many people don't remember this, but there was a drug that came out called Vioxx. It killed tens of thousands of people, and no one noticed for 5 years. And behind this, there's probably an entity resolution problem, because in one database, this is about unlabeled data. How is machine learning going to learn if you give it this database with names, dates of birth, and prescriptions, and this database with names, date of births, and deaths? This is the Social Security Administration sells a death master. You really have to entity resolve this kind of data and flatten it out so that you get name, date of birth, prescription, and death. And now you've just labeled it. You've now taken prescriptions and labeled it with death. And so that gives you, it's a form of auto labeling, and the most simplistic machine learning could find problematic drugs much faster than having to wait for a few doctors to realize it was their patients on Vioxx. That was the pattern. A little more technical deep dive. Under the covers of entity resolution, you receive a record, you map it, and you standardize its features. That's, for example, in an address. If you just have one big long bag of words, you want to try to figure out which part's the apartment number, which part's the city state versus a region. You want to compute new features, like you want to take a name and a postal code and kind of put those together so that you can easily find it as a candidate. And you build candidates. So what allows entity resolution to be fast is you get an inbound record. You don't want to go scan all billion identities to see who it is. You want to figure out a subset of candidates. So you're gonna say something like, well, give me everybody with the same name and date of birth. Give me everybody that's ever lived at the same address. Everybody with the same phone number or email. So you determine what kind of candidates you want. Then you go fetch them. Then you compare the features. So now you've got your inbound record. You've got candidates. So you're going to use a name comparator to compare names, and an address comparator to compare addresses, a date of birth comparator to compare date of births. There's a special way you want to compare socials. There's some socials that are valid socials, but they were used on billboards, so they're not really valid. So a good social comparator would know that. Then our magic's in applying our principles. We came up with a way. We have a paper on this about principle-based entity resolution. It's out in the wild. You can find it. But principles say if If entities are named similarly and have similar IDs, they're probably the same. If entities have similar names but they have different, dates of birth, they're not likely to be the same person. So here it's making a decision about, are they the same, are they related? And if it learns something, then it kind of has to do a real-time learning loop. Then you update the database and you publish out to graph databases or complete the process. Okay, let me see how much time I've got left. 4 minutes. I'm going to do this really fast. There's a lot of interesting problems with popular AI and ML these days that are great for other domains like detecting kitty cat images, but not for real-time entity resolution. It's tough to find all the labeled data. Models tend to be not very resilient with current AI and ML. I don't know if you've seen this, but you can take that picture of a bus, change some pixels so it still looks like a bus, and the models tell you it's an ostrich. You can take that little hen, tells you it's an ostrich. You can take that Indian temple, I think, change a few pixels, and it'll tell you it's an ostrich. You can change a few other pixels and thinks it's a robin, a cheetah, an armadillo. That's because of the brittle models. You also have to train it in domains. If you train it on US people, then it doesn't just go and work on Singapore companies or global vessels, ships in Mandarin. And it's not explainable on refresh cycles. We have a paper about what we're doing that's kind of unique, but the one section in this paper that really talks about our unique AI, which I'm gonna, in the interest of time, not cover this chart actually, but what we've done, I was inspired by a Wired magazine article that says, how come AI has lost doesn't have any common sense? And I went, wow, what a great way to explain what we've been doing. We have a common sense layer, so it's smart on the first couple records. And then we have a real-time learning layer that overrides common sense. And these two are kind of like, they interact off of each other. So it's smart out of the box, but then gets smarter over time. As it gets smarter over time, like over time, it might learn that passport number 123456 is a lousy passport number, like 500 people have that. The moment it learns that, it doesn't think that it knows passport numbers are good, but not that number. And it goes in the past and goes, well, did I mess up any before I realized that? And so in the type of AI that we've built, or ML, I should say, that we've built, it doesn't have these same deficiencies that we can't have in real-time entity resolution. Here's a quick architecture picture. You take source data. For us, other entity resolutions engines are the same way, by the way, but you map it to some kind of standard input document, and then you drop it on a queue. And then we have an SDK that you post to. We have a stream loader or a REST service you can post to. And we write it to a SQL database like Postgres or Aurora on Amazon or others. And then in real time, you're publishing interesting parts of the graph in JSON to an output queue. And then you're passing, now you're done with entity resolution. Then you do decisions. You do risk scoring, red light, green light about a decision. Maybe you're doing notifications. Maybe you're publishing it into Elasticsearch or Neo4j or some other graph. Maybe you're dropping it into case management, or maybe you're improving a link chart, which I think this is my last chart actually. Here's the difference, by the way. This is I2 Analyst Notebook, if any of you have ever seen this, but this is a very kind of realistic kind of graph of what happens when you don't have entity resolved data. It would take somebody trying to make a decision a bit of time to assess that, but if you've entity resolve it, it actually is this. And so it just creates a lot of simplicity and accelerates decision making and improves decision making. Theatrical pause. 1 minute left for Q&A. Boom. By the way, before any of you drop, I'll just say I answer every email I get from everybody. So if anybody wants to email me, whether it's about, I don't care, Senzing, or I do triathlons, if you want to talk about those, I don't care. Shoot me an email. I'm there. Okay. That was my custom deck. Anybody still on the line?
That was fantastic. I'm curious, Jeff, how do you think this is going to impact the data career field? I mean, I would think that free up a lot of time for data scientists and DBAs. There's a shortage of talent in that space. I mean, how do you see this impacting, the overall data field?
Today it's just only in the last 6 months did I realize, as I think about, call it competitors in the space, there's lots of companies that do entity resolution. I realized that most companies are just trying to do this homegrown. They'll have 3 or 5 people who've been working on this full time, like for a decade. And I think it's going to free them up to do more important work. Like, why would anybody try to write a database these days? It's just commoditized. I mean, yeah, anyway. And so because now entity resolution is just commodity priced, super cheap, I think engineers aren't going to work on that part of the problem. They're going to work on, you still have to map data, and that's actually a little more, not the brainsy part of the business. But on that last architecture chart, all the stuff on the right, the risk scoring models, how do you visualize things? I think that's where there's an enormous amount of creative work to be done. So I think there'll be a little bit of a shift where, like literally, like fuzzy matching, why isn't that just a mundane part of the problem? Like, why has it been consuming so many calories? So anyway, I think where people have been focused on that, I think they can get onto more interesting work now. And I think it's going to create more value when organizations have better models. And when the data is better entity resolved, you do get better models. It's not 5 people with 5 transactions. It's 1 person with 5 transactions.
Yeah, that's absolutely. I think that's really interesting. And so I'm always kind of, trying to track kind of what the trends are and what to expect. And so that's good to hear.
This is Michael. I've got a question too.
I'm good.
It looks like this is doing a lot of analytics and analysis on the back end or the after the fact. Are you working on integrating this where it does it on the front end, like people are in this new entry and it detects it and says, hey, is this possibly these other ones, the possible matches, existing ones, and that?
You know what? That's a great question. This chart I'm showing right here, you're the first, this call is the first time I've ever presented this outside of Senzing. And this chart is that. So your question helps me imagine how to improve this before we commit this to a nice little paper. This is all real time. So the story that I've got to figure out how to make this chart show is you're onboarding a new customer. That is precisely the same in real time. It hits this ingest queue. This output queue tells you, hey, that's your customer on this other, they're over there in their wealth management database, or they're over there in this other database. You've already onboarded them before. And that is milliseconds, literally milliseconds. Maybe what I need to do is make an onboarding over here. It's like an onboarding decision. Ooh, maybe that's what I should do. Anyway, the answer is yes, it is deployed that way. In many use cases, it's that way. We have a financial, I'll give you an example. We have a financial institution. They have a watch list database of 2 to 3 million. It's politically exposed persons. It's sanctioned parties. It's, I don't know, money launderers and other stuff. Every global transaction, while it's happening, get pings against it. And it comes back with, is it a match or not? Because it's 3 million records, I haven't mentioned price earlier, but I feel like you got to know this because this is unheard of. They pay $8,500 a year. Like, it's just chump change to make a real-time, high-quality decision like that. So, anyway, yeah, it's designed for that purpose. A lot of organizations, though, start with batch, but like the comfort to know they can get to real time. But real time onboarding of customers, real time transaction for risk, we get used for continuous vetting, like for labor. Labor, yes. Continuous insider threat vetting, continuous supply chain. Did I answer your question good enough?
No, that was fantastic. Thank you very much.
Yeah. Hey, if anybody wants to try it and wants Our free license is like well, it's 10,000 today, but it'll be 100,000 records in a few weeks. But if anybody wants to try this on 1 million, 10 million, a $500 million, just shoot me an email and I'll send you a free, unlimited, no cost license. You can try it.
Jeff, it looks like we have another question on the board there in the chat. You don't entertaining that one?
I can't see it. Can you tell me about it?
It says it's from Josh Vertalka. It says the healthcare industry is one area that desperately needs entity resolution, but there's often hesitation because of privacy issues. So I was wondering, how would you perform accurate entity resolution while protecting sensitive data?
Okay, when organizations own the data themselves, so you're not talking about information sharing, then it's not so much a privacy issue, and they still struggle with it. They call it patient record matching, and those systems are either expensive to be homegrown or are expensive to buy commercial products. So there's options. There's more options there now. The challenge around privacy is, what about when you want to share healthcare information in an ecosystem? So like the HIPAA law, for example. So when you get two organizations that want to share, our privacy enhancing feature called selective field hashing allows both sides to hash the data so that the union to find out that there's entity resolution doesn't reveal to the matching party any of the data. We have a paper that was written about that while I was at IBM, written by Peter Swire, who was the author of HIPAA, about how it comports with that. That method was also tested by the Sentinel program and published by the FDA, and it's had other vetting in the privacy community. So that's one way to do it. Hopefully that. If he wants to shoot me an email, I have a whole little email clip I can send him of some things to read about some of the different options to use it that way.
So Jeff, hi, this is Deborah. Jody asked a question. Principles sound like business rules, i.e. a deterministic approach, but I can only imagine there's more under the hood. Perhaps the principles are derived based on some ML algorithms.
Okay, here's my best example of principles. I was inspired. I went and met with somebody that was running fraud for a big credit card company, and I showed up and said, they started by just kind of puffing up and looking at me and said, Mr. Jonas, before I tell you anything, I just want you to know we have 10,000 rules. And at the moment, I didn't really know how to respond to that, but something told me that was a funny kind of way to brag. And it took me a few months, and then I finally did a blog post called Hell with Rules. And here's the difference between rules and principles. A rule would be like telling your kid, don't throw rocks at cars. But then your kid comes back, then you find your kid throwing rocks at SUVs. You're like, hey, don't throw rocks at SUVs. And then it's at buses. And then your kid's 35 years old and they're throwing iPads at Segways. And you're like, hey, don't throw iPads. Like, how many rules do you need? It's like you have to be stung by every kind of bee of every size and every shape and every coloring. And until you can teach your kid a higher level principle, like don't throw stuff at other people's things, unless you're at risk. That's moving it up to a principle level. Within our principles, what I did is I studied across domains. How do you entity resolve people? How do you entity resolve cars? How do you entity resolve routers? Like routers are make, model, color, IP address, MAC address. And I thought about those domains horizontally and came up with a set of standard principles that work across all those domains. Could I have used a machine to find that? Maybe, but I was able to actually do it on a piece of paper myself and go, it's obvious. And so we have a finite set of principles. It's under 30 that work across every domain. And what's interesting is when we get feedback loops from our partners about any false positive or false negatives, when we tinker in the engine, it actually fixes other domains. Like we'll fix something for vessels and it'll make it better for everybody else. In our Uniquely Senzing paper describes the type of learning that we're doing. It's it's micro level learning. We learned that that person also has a middle name Jack. That's not like a big macro trend. It's like somebody named Tom also has a nickname Jack. And when we learn that, we find all the other Jacks that could have been them. And we also learn statistical things like phone numbers that are phone numbers that are maybe toll-free phone numbers for travel agencies that might occur on a lot of records. We learn about those statistically in real time. Are there other things that we've got eyes on for real-time learning? Yes, but we're favoring styles of learning that are real-time and not batch. And at the moment, all of our learning is on the fly, no reload, and we don't stumble up. A lot of algorithms stumble up. If 5 families from Somalia move into a small town from some immigration program, the algorithms are very likely to start fouling those up because they're unseen names. That does not happen to us. We don't have that vulnerability, but it's described more in the Uniquely Senzing paper and in our principle-based ER paper. You could also say that we have a blend of deterministic and probabilistic. The whole debate about do you want deterministic or probabilistic systems have always been like, why are you saying or? Why not and? Anyway, maybe I've not made the person asking that question feel fully satisfied. Sorry.
No, you did. She responded, thank you.
Oh, okay. Like, oh, maybe I've left somebody unsatisfied.
Yeah, and by the way, if you're not seeing the chat, everyone is saying awesome presentation, fantastic information. They love the deck.
Oh,
excellent presentation.
I'll send anybody the deck if you want it. I'll send you some links to the papers. Hey, I've got an entity resolution group I've created on LinkedIn, and I'm inviting people to it who just care about it. And it's right now I'm like, it's a kind of a new upcoming group. So I'm trying to get more people to post there, but I post what other people are doing in entity resolution and interesting case studies. I'm just trying to find entity resolution kindred spirits that care about it. So if anybody wants to be a part of that, find me on LinkedIn.
So Jeff, this is Michael. I've got a couple more quick questions if you have a second.
Yeah.
So 2 questions. The first one is, as a whole, because obviously people are taking different approaches, but as a whole, are you seeing more active resolution where when entities have these possible matches, that they're using that as a small subset and actually going out actively to try and resolve them now that they have a filtered list? Or are you seeing more passive of just let it keep learning and figure it out eventually?
At scale, a lot of our users have hundreds of millions of records. Like we have some in the tens of billions plus. At these scales, you end up with a lot of maybes that exceed like human curation. The good news is as new records get loaded, like record 6 in my example, it automatically corrects. So that is probably the most common thing. In smaller data sets where you have the capacity to look at the maybes, you can do that. We can also triage the maybes and tell you the ones that are the most, the highest probability, and you could just look at those, or the ones that have a nexus to something spooky. It's like, yeah, maybe they're roommates. And if you ask yourself the question of if they were roommates, would anybody care? And if the answer is no, even if, I mean, are they roommates or are they the same people? Would anybody care? And you're like, no, this is a marketing system. Maybe Jeff Jonas, maybe we'd accidentally sell him a hair care product, market a hair care product to him. So in those cases, you could skip those. But we have something coming, which I've not been talking about publicly. So under FriendDA, if you've heard of that, we have a feature that is going to get onto our roadmap. It's on our roadmap, and we're going to start it soon, called selective curiosity. And in a nutshell, selective curiosity says there's not enough compute budget and time to be curious about everything. I'm not sitting in this room here going, wow, what color Pantone white is that on the wall? Same in an entity resolution system. There's a whole bunch of maybes that aren't worth being curious about. It's like, are they the same? Are they roommates? Who cares? But man, hey, are they the same? Man, if they're the same, we're going to make a different decision. What if the machine would notice that was a case it needed more information? And what if it went out on an API to LexisNexis or TransUnion TLO and did a fetch on an API and pulled back that data and added the record and went, oh yeah, it's a junior senior. And in the moment, you can make a better decision without a human in the loop with higher confidence. We're super excited about that.
That actually went along to my second question I was going to ask is, are you starting to have available, publicly available or databases that can be queried against for various things? Obviously, like you're not going to have health records as a public, prepared database, but things like, LexisNexis, other things that you can go and you can do these kinds of things off of.
Yeah, our partners, customers, partners, and all definitely do that. And we have a bunch of open source connectors, like for Dun & Bradstreet. Like in financial institutions, you want to know corporate hierarchies. You have an obligation in banks to know who is the ultimate beneficial owner, who actually owns the company. That's data that Dun & Bradstreet owns. We have connectors for Bureau van Dijk at Moody's, Dun & Bradstreet. There's a company called Open Corporates out of the UK that has some great data as well. There's some cheaper data that you can buy about companies around the world. It's a little bit older, but it's kind of interesting because it's so cheap. It tells you if they were in business 3 years ago or 5 years ago. OFAC database, deceased persons database. Those are all great sources. I didn't mention this, but I sit on the board of a privacy policy group in Washington, D.C. called EPIC. And EPIC, we sue the government for spying. Like I do a whole bunch of privacy work. I'm on the advisory board of EFF, even though a lot of our customers are governments. So we take privacy and building in privacy features, we take that seriously. And a couple of things that we've done is like when people download our software, we don't even ask them for their email address. Like if anybody on this call wants to download it, the free version, we don't even know who you are. And we decided not to host anybody's data, and we decided not to be in the data business. But our partners go and go and acquire data from other parties, and we're trying to make it easy for them to do that. But it's your relationship with them. We're just trying to facilitate it and help companies get combined data and get better results faster.
Thank you. Appreciate it.
Yeah.
So Larry also wanted to know, are you working to put the app on a mobile device?
Well, we're really just, it's best to think about us as an API, like you call us. You can either compile us into Java, Python, or C. Like literally, we're a link library. So we really don't have a user interface. I mean, I did show you our little desktop app, but that's kind of like right now, like if you own 3 pet stores and you have duplicates in your Christmas mailing list, like there's no remedy for you. We're trying to help the world solve that with our little desktop app. But could somebody build a little iPhone or an Android app, and some are noodling this, can they just license my stuff because it's so cheap and make it the core engine behind an address book cleanup that'll run on your iPhone or Android? Sure. But we'd probably be behind the scenes somewhere, and it would be somebody else running the data. The download's 1.3 gig, I think. Like the way we match names, it's machine learned, like traditional machine learning off of an 800 million name data set. So it's 300 gig. Our ability to parse global addresses, so you don't have to have address hygiene software, is trained off of OpenStreetMaps. I think that's, I don't know, that might be 600 gig. So it's not really a phone. You don't run the phone. You don't run this entity resolution engine on the phone, but you could build an app that connects to it.
Terrific. Have you ever been to New Mexico, Jeff?
Probably. Not recently.
Driving through I-40 in the 1970s?
I don't recall going through. I have been there once, but I think I this place on the 4 corners. Isn't there a point there where you can stand like somewhere and it's like got all 4 corners?
Yep, absolutely. Well,
Okay.
Once we can, we'll love to host you. And we have an annual conference called Experience IT. Your presentation was just fabulous today. And
Thanks.
Typically in New Mexico, we end off events and that kind of thing with, what's your preference, red or green? but we'll just prep you for that. And that really means so red chili or green chili.
Oh, I see.
Because we have the best chili in the world here in New
That's
Mexico.
awesome. Okay, well, red, but I know it's a little early for that. I have time to change my mind, I guess. Well, listen, thank you for having me, asking me to join and kick off this big data series thing, and love to hear from anybody on any topic.
Yeah, thank you so much for joining us. We really appreciate it today. It was really fascinating.
Thanks. Bye, everybody.
Thank you. Have a good day, everyone.
Thank you, Jeff.
Thank you.